Okay, today we continue with the rest of chapter 3. We start with data dictionary and system catalog. So what is data dictionary? Data dictionary actually detail description of all tables found within the user or designer created database. So it contains at least all the attribute names and characteristics for each table in the system. Contains metadata, which is data about data, and sometimes data dictionary is described as the database designer's database because it records the design decisions about tables and their structures. Okay, let's look at the sample for data dictionary. Okay, this is a simple data dictionary for two tables, which is customer and agent. Okay, so first we have a table name, attribute name, okay, whereby we list down all the attribute for these two tables and then the meaning of each attribute. For example, CAS code means customer account code, and then the type of the attribute. Okay, for example, customer code can be any character with a length of 5. Okay, and then this is the format. Okay, 6 uh, numbers. Okay, range from 10000 up to 999999. Okay, and then we have to state whether this field is required, this attribute is required or no. Okay, why? Yes, if it is a required field, compulsory to be filled in, you have to put it Y, and then if it is PK, put it PK. Okay, then if that attribute is FK, you have to put it FK. Okay, then for example, for the date, you have to specify the format. Okay, okay, then if it is phone number, okay, the length is 8 character. Okay, so kalau you belajar programming, karakter pun boleh digunakan untuk number. Okay, so this is the format, the range from here this to this. Okay, this is one example of sample data dictionary. Okay, next we move to system catalog. So what is system catalog? Contains metadata. It is actually detailed detailed system data dictionary that describes all objects within the database. Okay, so including table names, tables creator, creation date, number of columns in each table, data type for each column, index file names, index creators, authorized users and access privilege. Okay, so sistem katalog ni adalah sistem data dictionary yang lebih detail. Okay, about index we will see later. Okay, so sistem katalog ni dia akan list down lebih banyak info. Okay, siapa pencipta table tu, bila table tu diwujudkan. Okay, siapa pengguna yang dibenar authorized users dan apa access privilege dia. Contoh user ni boleh access, boleh read only, yang ni boleh read and edit or whatever. Okay. Okay. Okay, next we move to homonyms and synonyms. Okay, what is homonym and what is synonym? Homonyms are similar sounding words with different meanings, identical spelled words with different meanings. In database, the use of the same attribute name to label different attributes. Okay, for example, C underscore name in customer table and C underscore name in consultant table. Okay, katalah kita ada dua table, satu customer table, satu consultant table. Okay, dan customer table untuk attribute nama customer tu, dalam table customer dia guna C underscore name, dalam table consultant C underscore name tu pun digunakan untuk consultant. Maknanya dua spelling yang sama tetapi merujuk kepada attribute yang berbeza. Satu merujuk kepada customer, nama customer, satu merujuk kepada nama consultant. Okay, so that is homonym. Ejaan sama tetapi merujuk kepada attribute ataupun attribute yang berbeza. Okay, synonym, different names to describe the same attribute. in database, same attribute occurs in different table with different names. For example, auto and car, same meaning. Okay. Okay, so ni sinonim attribute yang sama tetapi ditulis dalam dua ejaan yang berbeza ataupun dua nama yang berbeza. Okay, next we come back to these three types of relationship: one to many, one to one, and many to many. Okay, so this one I have mentioned previously. Okay, let's refresh back. Okay, one to many is a relational modeling ideal. Should be the norm in any relational database design. One-to-one relationship should be rare in any relational database design. Jaranglah satu one-to-one relationship. Okay, then many-to-many relationships cannot be implemented as such in the relational model. Okay, we will see later. I will explain why. And then many-to-many relationships can be changed into two one-to-many relationships. Okay, jadi dia kata kalau untuk many-to-many, dia tidak boleh implement dalam relational model. Sebaliknya dia akan ditukarkan boleh ditukarkan kepada dua one to many relationship. Okay, we will see later. Okay, first one to many relationship. Relational database norm means found in any database environment. Make sure that the primary key of the one is included as a foreign key in the table of the many. Okay. Maksudnya, okay, untuk contoh, okay, let's look at figure 3.18. Okay, this one shows one-to-many relationship between painter and painting. Okay, seorang pelukis boleh melukis, okay, satu atau banyak lukisan. Okay, so data tentang painter ni tidak boleh, maksudnya dalam table painting akan ada maklumat tentang painter. Okey, kalau pelukis tu melukis lebih daripada satu lukisan, okey, bermakna data tentang pelukis, seorang pelukis yang melukis lebih daripada satu lukisan, okey, data dia akan wujud lebih daripada satu kali di table painting. Okay, so that's why dia kata make sure primary key of the one, okay, contohnya di sebelah, di one side ni, okay, is included as a foreign key in the table of the many. So maksudnya contoh kalau saya ada painter code, okay, painter code akan menjadi primary key di dalam table painter dan dia akan menjadi foreign key dalam table painting. Sebab apa? Kita tak akan ambil primary key daripada painting untuk diletakkan dalam table painter. Sebab apa? Sebab satu painter berkemungkinan melukis, okay, satu pelukis boleh melukis lebih daripada satu lukisan. Okay. Jadi logiknya painter code will be the foreign key in the painting table. Okay, nanti bila kita dah buat exercise, we will see the effect. Okay. Okay, biasa student akan tanya yang mana satu nak jadi foreign key, sama ada painter code ataupun painting code. Okay. So yang lebih sesuainya adalah painter code. Okay, akan menjadi foreign key di dalam painting, table painting. Okay, this is the explanation. Okay, we have table painter. Katalah ada primary key painter 6. Painter 6, okay, the code given for each painter. Okay, so in table painter, no foreign key. Okay, we just have painter 6, painter last name, painter first name, and painter initial. And then second table painting, the primary key is painting number. And then we have painting title. Okay, then painter 6. So you can see here, one painter can draw one or more paintings. Okay, so you boleh nampak kat sini, satu painting Okay, contoh painting number 1338 is painted by painter number 123. Similarly, for painting number 1339, also painted by painter number 123. Okay, and then also this one, painting number 1341. So, painter number 123 has painted 3 paintings. Okay, jadi painter number akan menjadi foreign key di dalam table painting. Okay. Kalau kita nak letakkan painting number di dalam table painter untuk dia menjadi foreign key tidak sesuai. Kenapa? Sebab seorang pelukis boleh melukis lebih daripada satu lukisan. Jadi kalau kita letak painting number sebagai foreign key tak sesuai sebab dia satu pelukis ada lebih daripada satu painting. Okay. Hope you can see the effect. Okay, kenapa kita letakkan painter number sebagai FK dalam table painting, bukannya painting number di dalam table painter. Okay, this is another one-to-many relationship, okay, between course and class. Satu kursus, okay, one course can have one or many classes. Okay, contoh Ict200, okay, can have one or more classes. Okay, boleh ada satu atau lebih kelas. Tetapi satu kelas, contohnya Ict200 untuk Ict200 untuk group E. Sorry. Okay, contoh kelas pada pukul 8 pagi hari Rabu untuk kelas 3E akan merujuk kepada kursus ICT 200. Okay. Okay, tapi ICT 200 boleh jadi untuk kelas 3E hari Rabu pagi, untuk kelas 3A hari lain. Okay. Ada banyak kelas. Okay. So this is the implementation of one-to-many relationship between course and class. Okay, macam saya bagi contoh tadi. We have two tables, table name course and table name class. Okay, katalah course code ACCT211. Okay, and then we refer. Okay, for this one, primary key course code, foreign key none. And then we refer to table class code, then foreign key course code. Okay, for example, class code 10012. Okay, the course code, this is the foreign key, ACCT211. Okay, class section, mungkin ni macam group dia lah. Okay, class time, classroom, dan dia punya professor number. Okay, so similarly, course code ACCT211, class code 10013. Okay, section 2 untuk group 2, class time dia lain. So you can see that the same course code can appear more than one time in the table class. Okay. Dan tidak sesuai untuk kita letakkan class code di dalam table course. Okay, class code tidak sesuai menjadi foreign key dalam table course sebab satu course code boleh ada banyak kelas. Okay, tetapi satu kelas hanya merujuk kepada satu class code hanya merujuk kepada satu course code. Okay. One-to-one relationship, one entity can be related to only one other entity and vice versa. Sometimes means that entity components were not defined properly, could indicate that two entities actually belong in the same table. Okay. As rare as one-to-one relationship should be, certain conditions absolutely require their use. So, untuk one-to-one relationship ni jarang berlaku. Biasanya one-to-many ataupun many-to-many. Okay. So, dia kata one-to-one relationship kemungkinan besar entity komponen tu tidak define secara sempurna. Okay. Dan kemungkinan dua entity itu adalah sepatutnya berada dalam satu table. Okay, this is one-to-one relationship. Okay, for example, one professor chairs one department and only one department. Maksudnya satu profesor boleh menjadi chairman kepada satu department dan satu department hanya dipenguruskan oleh satu profesor. Macam dekan lah, satu dekan, satu lecturer. Dekan tu lecturer ataupun profesor. Dia boleh menjadi dekan kepada satu department dan satu department hanya boleh ada satu dekan. Itu contoh one-to-one relationship. Okay. Okay, this is the example of one-to-one relationship. Okay. So, kalau you tengok tidak ada pengulangan di okay, kita ada table name, professor, primary key, employee number, foreign key, department code. Okay. Then we have table department, primary key, department code, foreign key, employee number. Okay. So the one-to-one professor chairs department relationship is implemented through the placement of the employee number, foreign key in the department table. Okay, next. The many-to-many relationship can be implemented by breaking it up to produce a set of one-to-many relationship. Okay, can avoid problems inherent to many-to-many relationship by creating a composite entity or bridge entity. Okay, kita akan tengok nanti apa itu composite entity ataupun kita namakan juga dia sebagai bridge entity. So, composite entity table must contain at least the primary keys of original tables. Linking table contains multiple occurrences of the foreign key values. Okay, I will show you based on table, barulah you nampak. Then additional attributes may be assigned as needed. Okay. So, for example, many-to-many relationship between student and class. Okay, seorang student boleh has one or many classes, and one class can be joined by one or many students. Satu pelajar boleh join satu atau banyak kelas, dan satu kelas boleh di-join oleh seorang ataupun banyak student. Okay, so many to many. Okay, so for example, let's consider this sample student enrollment data. Okay, student's last name Bowser, selected classes accounting 1, okay, accounting 211, code 10014, intro to microcomputing CIS 220, code 10018, intro to statistics QM 261 and code 10021. And similarly for Smith son, okay, the same classes, both of them are in the same class. Okay, so let's consider this table. Okay, katalah bila kita nak buat relationship tadi, nak show dalam table. Okay, dia akan jadi macam ni. Katalah ada dua table student, okay, primary key, student number, okay, no foreign key. And then we have table class code, and foreign key dia adalah student number. Okay, so kita boleh nampak di sini, since seorang student boleh ambil banyak kelas. So, Bowser tadi, class code dia 10014, 10018, 10021. Okay, let's check. Okay, 3 kelas. Sama juga dengan Smith son. Okay. So, what happen? Dia akan ada banyak redundancy dalam table student. Dan begitu juga dalam table class code. Okay. Class code untuk 10014 untuk student Bowser tadi. Okay. Satu row. Dan class code 10014 untuk student Smith son tadi. Okay. So, akan ada redundancy lagi di sini. Okay. That's the effect of many-to-many relationship. Okay. So, bila kita buat database, kita tidak mahu redundancy macam ni. Okay. Tidak mahu ada terlalu banyak pengulangan. So, you can imagine, kalau satu kelas tu ada 30 student, bermakna kita akan ada 30 baris yang sama untuk satu kelas kod. Okay. Ni maksudnya kalau ada 2 student, kita akan ada 2 pengulangan kelas kod yang sama sebanyak 2 kali. So, you can imagine kalau ada 30 student, akan ada 30 row redundant kat sini. Dan begitu juga dengan student number. Kalau seorang student tu ambil 8 subjek, bermakna akan ada 8 pengulangan student number di dalam satu database. Dan you can imagine kalau ada beribu student. Okay, betapa banyaknya redundancy kita ada bila wujudnya many-to-many relationship. Okay. Jadi, solution dia, okay, we have to convert the many-to-many relationship into to one-to-many relationship. Jadi, untuk mengurangkan redundancy yang saya tunjukkan dalam slide tadi, we can convert many-to-many relationship kepada 2 one-to-many relationship. Okay. Okay. So, kita tengok macam ni. Kita ada satu table student dan hanya ada student name and student last name. Okay, hanya untuk menyimpan nombor pelajar dan nama pelajar. Then we have another table class, hanya menyimpan course code, class section, class time, classroom, professor number. Okay, dan foreign key dia adalah course code. Okay. Then kita ada satu table baru iaitu composite entity ataupun kita panggil juga sebagai bridge entity ataupun bridge sahaja. So table name ni kita namakan dia sebagai enroll. Primary key dia adalah kedua-dua class code dan juga student number. Okay, ni adalah composite key. Okay, yang saya explain sebelum ni, apa itu composite key? Bila mana primary key tu terdiri daripada lebih daripada satu attribute. So, inilah contohnya. Primary key di sini adalah class code dan student number. So, foreign key pun sama. Class code, kita akan ambil benda yang sama, attribute yang sama, class code dan student number. Okay, foreign key ni class code, student number. Primary key, kedua-dua. Combination of class code and student number. Okay, so contohnya saya nak tahu enroll grade untuk seorang pelajar. So, mestilah kita combinekan nombor pelajar dengan kelas apa. Contoh saya nak tahu grade pelajar saya untuk subjek database. So, of course saya kena tahu matric number dia dengan kelas code dia. Okay. So, kalau sekadar student number, tidak memadai untuk saya tahu grade pelajar saya dalam database. Okay. So, this is the composite entity. Okay, this is how we change many-to-many relationship to one-to-many relationship. Okay, asalnya one student can be joined by, one student can join one or many classes. One class can be joined by one or many students. So, many-to-many. But because of the problem of redundancy, kalau kita keep in this many-to-many relationship, kita pecahkan kepada 2 one-to-many relationship. Maksudnya, satu student boleh ada, can register or can enroll in, can have one or many enrollment. And then, one class can have one or many enrollment. Okay, so dia akan jadi macam ni. Kita letak composite entity ataupun bridge di tengah. Okay. Okay. So, this is ERD for tiny college. Okay. The expanded entity relationship model. Okay. Okay. Tengok. Ni yang tadi. Satu student boleh join satu atau banyak kelas. Satu kelas boleh ada satu ataupun banyak student. Okay. So, jadi dia akan pecahkan kepada enroll. Bila mana you ada many-to-many entity, many-to-many relationship, you boleh create satu lagi bridge kat tengah ni dan jadikan dia one to many, yang ni pun one to many. Jadi bridge dekat bridge ni akan jadi many dengan many. Di kiri dan kanan dia many dengan many. Okey, dan dia punya foreign key ambil daripada sini satu, ambil dia sebelah kanan satu, sebelah kiri satu. Dan dia punya primary key dia adalah gabungan kedua-dua daripada kiri dan kanan table dia. Okey. Dan satu kod kursus boleh ada banyak kelas dan satu kelas hanya merujuk kepada satu kod kursus. Okay, this is the expanded entity relationship model. Okay, this is the relational diagram for tiny college. Okay, so this one is ERD, please don't get confused. Okay, this one relational diagram. Okay, relational diagram dia punya simbol 1 dengan infinity. Okay, to represent one to many. Okay, similarly for this one to many. Okay, so kalau kita tengok di sini, the primary key is student number. Okay, for table student. And the primary key for table class is class code. And then, this is the bridge or the composite entity. Okay, dia akan ambil primary key dia, combination of class code and student number. Okay, dan foreign key adalah class code dan juga student number. Okay, for this one course can have many class. Okay, so course code akan menjadi foreign key dalam table class. Okay. Okay, next we move to data redundancy. Okay, revisited. Data redundancy leads to data anomalies. Such anomalies can destroy the effectiveness of database. Okay. Okay. Kenapa dia kata redundancy can create anomalies? Okay, contohlah. Saya tunjuk table yang tadi. Okay. Kalau macam ni, kita ada banyak pengulangan nama pelajar yang sama. Contohnya Bowser, 3 kali. So, you can imagine kalau Bowser ni ambil 8 subjek. So, nama dia perlu di key in sebanyak 8 kali. So, kalau berlaku kesilapan ejaan dalam salah satu data, okay, dia dah berlaku error. Okay, walaupun orang yang sama, database ni akan treat sebagai orang yang berbeza. Okay, so that's tu salah satu masalah jika berlaku jika ada terlalu banyak redundancy, kemungkinan salah masuk data disebabkan ejaan. Okay. Okay, and foreign keys control data redundancies by using common attributes shared by tables. Crucial to existing data redundancy control. Sometimes data redundancy is necessary. Okay, pun begitu, data necessary ada kalanya berguna. Okay. But we have to control data redundancies by using common attribute. Okay, shared by tables. Okay. Dengan penggunaan foreign key, kita boleh control data redundancy. Okay. For example, this one, a small invoicing system. Okay, kalau kita tengok the first table, table customer, primary key dia adalah customer code, but there is no FK here. And then second table, table invoice. Okay, primary key dia adalah invoice number dan foreign key dia adalah customer code. Okay, so kita fikir logik. Satu customer, bila kita buat pembelian, satu customer boleh ada banyak, boleh can create one or many invoices. Tapi satu invoice hanya kepunyaan satu customer. Okay, so kita boleh tengok kat sini, invoice number, for example 1001 belongs to customer 10014. And then invoice number 1002 belongs to customer 10011. Then similarly for invoice number 1004 belongs to customer code 10011. Maksudnya satu invoice hanya belongs to satu customer, tetapi satu customer boleh ada lebih daripada satu invoice sebab mungkin dia buat pembelian banyak kali dan setiap kali pembelian dia akan diberi invoice yang berbeza. Tetapi satu invoice, okay, you can imagine kalau you beli barang, resit tu kalau kepunyaan you, hanya kepunyaan you. Tidak mungkin resit tu dikongsi dengan customer lain. Okay, so that's why foreign key bagi table invoice ni adalah customer code. Okay, next we have this one, table name line, primary key dia invoice number plus line number, and then foreign key dia invoice number dengan product code. Okay, so dia link pula table line ni dengan table product. Primary key untuk table product adalah product code. Okay, tidak ada foreign key. Okay, so satu invoice tu boleh ada okay, as you can see here, okay, one invoice number, okay, can have two different product code. Okay, dalam satu invoice, okay, boleh ada maklumat tentang lebih daripada satu produk, satu atau lebih produk. Tetapi satu produk hanya merujuk kepada satu vendor sahaja. Okay. Okay, for example, vendor code 232. Okay, the product code, the first one and the fourth row. Okay, satu vendor boleh mengeluarkan banyak produk, tapi satu produk hanya dikeluarkan oleh satu vendor. Okay. Okay, next. This is the relational diagram for the invoicing system just now. Okay, we have customer code, which is the primary key for table customer. And then for table invoice, invoice number is the primary key. And then the customer code will be the foreign key. Sebab satu invoice hanya kepunyaan satu customer. One customer can create many invoices. Okay, but one invoice belong to one customer only. Okay, then one invoice. Okay, ni sebenarnya many to many relationship. Satu invoice boleh ada banyak produk dan satu produk boleh ada banyak invoice. Okay, so dia akan ada composite entity here. Okay, so dia punya primary key is combination of invoice number and product code actually, and then dia punya foreign key adalah invoice number and this one line number. Okay. Sorry, the foreign key is invoice number and product code. Okay, and then dia punya primary key is combination of invoice number and line number. Okay. Okay, the last part for chapter 3, we have to see the term indexes. Okay, indexes is actually the arrangement used to logically access rows in a table. So we have index key. What is index key? It is index reference point, points to data location identified by the key. So unique index in which the index key can have only one pointer value row associated with it. Each index is associated with only one table. Okay, let's see example of index. Okay, figure 3.32. Okay, we have index key 123 and 126. Okay, pointers to the painting table for 123 is 124, and then pointer to the painting table for index key 126 is 35. Okay, what does it mean? Okay, we refer back to table painting and painter tadi. Okay. Okay, where is it? Okay, painter and painting. Okay, we refer back. Okay, this one. Okay, index key. Okay, kita tengok apa yang kita ambil. Yang painter number ni akan menjadi index key. Okay, 123 dengan 126. Okay, untuk painter number 123, lukisan yang dilukis oleh painter bernumber 123 adalah pada row 1, row 2 and row 4. Okay. Okay, so that's why here the index key 123, pointer 1, to 4. And then the index key 1 to 6. Okay, we check the table painting and table painter. Okay, for 1 to 6, painter number 1 to 6, you can see that he or she has painted the painting number at row number 3 and row number 5. Okay, so the pointer will be 3, 5. Okay, so that's why here the pointers to the painting table is 3, 5 for the painter index key painter number 1 to 6. So that's how we write the indexes. Okay, on your left is the index key, and then on your right is the pointer. Okay, so by that we finish chapter 3.